Let's continue building a regression model to predict a continuous value, also known as a statistical forecasting model. I'll start by recapping the previous video. If you haven't seen it, it is series 0. Then I'll continue with the theory, simplified. Okay, so linear regression is a supervised learning technique, which means it trains on historic data of which the inputs and outputs are known. Once trained, it can then be consumed and used to make predictions or forecasts. Training is that process where we expose the algorithm to our historic data points, so both our inputs and outputs, to find the best fitting formula that describes these data points. The best formula is that where the function is closest to the historic data points. So while we expose the historic data points, it's going to try to make predictions on those and then see how far it was off. That's the error rate. And we're going to try to minimize the error rate. Let's break that down. So a simple function, y equals a times x plus b, which describes this line in which y we also call the target or the label or the output, which is in the case of predicting house prices, the house price. And then we have x, which we call the features, dimensions, or the inputs, which could be either the amount of bedrooms in our example, could be the size of the property, it could be the combination of the two or more. Then we've got our historic data points around here, and the function, which is training to minimize the error rate. So it's kind of readjusting itself. So if it's here, the error rate is too large. There as well, maybe right in the middle is the lowest error rate. How that then happens under the hood is trying to find the best values for A and B, which is B is the intercept with the y-axis and A is the slope, which the slope would be like the curve, but now it's a straight line. The intercept with the y-axis is how steep, let's say, so or how flat the line would be. The slope could also be more complex. Instead of a simple line, it could be like a more complex function. And we call A and B the parameters, the weights. And we're going to, the model is going while learning, these are going to be readjusted to find to result in the lowest error rate, to minimize the error rate. How the readjusting of those parameters or weights happens, something to do with gradient descent. I would ask you to study that yourself. And it's basically trying to find the local minimum by calculating, well, the slope. If it's too large, then it's going to go. Okay, then let's continue with a very simple example. So the house prices on the y-axis, the labels, or the outputs, or the targets. And then the features would be 1 bedroom, 2 bedrooms, 3, 4, 5, 6, 7 features, or the inputs. And the goal would be to be able to calculate the house price for a property with 7 bedrooms, as an example. Of course, there's more features. Could be the property size, could be the neighborhood, could be all kinds of, could be the season, could be all kinds of features can have an impact on that, but this is just simplified. A prediction, of course, is going to fall on the line and hopefully close to the real price. But this is a very simplified model with just one feature, so it's not going to be very useful in the real world. Then, if you know some real-world applications of regression, which there definitely are, do let me know in the comment section below. I listed a few below. forecasting monthly expenditures, which I found pretty useful in the Azure portal, basically projecting the estimated cost of my resource usage on Azure. Of course, it could be more complex than a few features. It could be more like a time series forecast thing that happens in Azure, but more about that later. Sales forecasting, simply trying to forecast the revenue or the sales, and in that way you can know how much stock you would require one month or the other. Then customer acquisition cost, I found that very interesting. It's like if you're spending money on advertisement and you know you're going to have an audience like that, and maybe a click-through rate or even a conversion rate of, let's say, 1%, and you can then basically estimate the return on your investment, which is pretty cool. How would you do that? Yeah, you would need quite some data on previous ad spend and results of that, so conversion rates and so on. A lot of data you may need for that. Okay, upscale, downscale resources in anticipation. I think data centers may be doing things like that, or you could do that yourself. Let's say you anticipate, well, you predict way more website visits, let's say, in specific seasons or on specific days, then you can kind of get an alert, be alerted, or automatically upscale and downscale based on predicted demand or need. So it's widely used in multiple industries for a various number of use cases. I added some case studies if you're interested. I'll put this notebook on my Patreon as usual. If you're not a member yet, do become a member. Okay, then there's a whole list. In healthcare, that's also a common example that, for example, based on your physical features, your age, your weight, you could predict the blood pressure or the risk of certain health issues. Sport analysis, player performance, team rankings, game outcomes. Okay, like, subscribe if this was useful to follow along for next episodes. To become a member, I'm going to drop the notebooks on there, not all of the data, but the code. And check out my Gisco.com product website